In this video, we will learn and apply the technique of solving a modulus inequality. Now, a modulus inequality can appear in different formats, so that is why I have broken it up into different cases. This is the first case that we are focusing on. A modulus on the left hand side of the equation, and on the right hand side there could be a constant, there could be some terms in x, or it could be a combination of both. So let's first apply the concept of modulus and let's open up this inequality. The thing inside the modulus could be having a positive sign lesser than or equal to a. The thing inside the modulus could originally be having a negative sign less than or equal to a. This inequality will remain as it is. This inequality will become x is greater than or equal to minus a. Remember the concept that when we get rid of a negative sign by multiplication or division, the inequality flips. Now, if I plot it on a number line, so this is a number line, and I'm writing negative a, this is positive a, this inequality is x is lesser than or equal to a. So this is lesser than or equal to a. This inequality is x is greater than or equal to negative a. So this is negative a, and greater than or equal to negative a. So we look at the overlapping region. The overlapping region lies between negative a and positive a. Therefore, the inequality after opening up, applying the concept, becomes like this. That means whenever we have the inequality x modulus less than or equal to a, it will be converted into x lying between two values, negative a and positive a. So this is a hard and fast rule that we will be applying. Similarly, if there is only a lesser sign, something like x modulus is less than a, it will open up and it will become x lies between negative a and positive a. So now let's start with some examples. Something like x modulus is less than or equal to 3. According to the concept, x lies between negative 3 and positive 3. Let's try out another question. Something like x plus 3 modulus is less than or equal to 4. Again, it fulfills this criteria. Instead of x, we have x plus 3. Instead of 3 on the right, we have 4 on the right. So x plus 3 in bracket lies between two values, negative 4 and positive 4. Our focus is to make x the subject. So x lies between negative 4, negative 3, 4 minus 3. Therefore, x lies between negative 7 and positive 1. Let's look at another example. Something like 5x minus 1 modulus is less than or equal to 3x. How is this question different from others? This time, on the right hand side, we see no constants, but instead we see an x term. But the rule is still the same. X modulus less than or equal to a. After opening up, x lies between negative a and positive a. This is in place of x, this is in place of a. The rule is still the same. 5x minus 1 in brackets lies between negative 3x and positive 3x. Now break it up into two pieces and solve it separately. If I look at the blue portion, 5x minus 1 is less than or equal to 3x. Make x the subject. So 5x minus 3x is less than or equal to positive 1. 2x is less than or equal to positive 1. Therefore, x is lesser than or equal to half. Similarly, if we focus on the green portion, negative 3x is less than or equal to 5x minus 1. Negative 3x, negative 5x is less than or equal to negative 1. Negative 8x is less than or equal to negative 1. Therefore, x is greater than or equal to 1 over 8. There is a small issue that I want to clarify at this point. That is about what is the rule for flipping an inequality? When does an inequality flip? A lot of people have this confusion that since there were two negatives, one on either side, the inequality should not flip. That's not the rule. The rule is whenever the coefficient of variable, in this case x, is negative, and we want to get rid of this negative sign, we will either use multiplication or we will use division. Whenever this is the case, therefore, the inequality flips. That is the rule. Now, let's solve this inequality. Let us first draw a number line. Let me label the values. The values are, if I move up, x is greater than or equal to 1 over 8 and x is lesser than or equal to half. So this is 1 over 8. X is greater than or equal to 1 over 8. The inequality is moving this way. And a little bit bigger value is half. X is lesser than or equal to half. The inequality is moving this way. Therefore, the overlapping region is the answer. Therefore, x lies between 1 over 8 and 1 over 2. So that is the first case that we discussed for modulus inequality, in which modulus is on the left hand side because that is how we opened it up. Less than or equal to a, this will always break up into x lies between negative a and positive a.